Section 11.5, Partial Fraction Decomposition. This problem says tell whether the given rational expression is proper or improper. If improper, rewrite it as the sum of a polynomial and a proper rational expression. So the first thing we're going to do is we're going to look at if this is proper or improper. So now the way to tell is, when I look at the top polynomial here, I'm looking at each term. In each term, I have three terms here. Okay, and with these three terms, I'm looking at the exponent on the variables. So then for this first term, which is here, I see that the exponent is 4. So that tells me this term has degree 4. And then I look at the next one here, and that has an exponent on the variable of a 2, so that's degree 2. And this is just a constant here, so any constant is degree 0. So when I look at the polynomial of this complete polynomial here, of all three of those terms together, I just take the largest degree term and I say, hey, that's the degree of that polynomial. So the degree of the polynomial on top is 4. And then I do the same thing to the bottom. Now the bottom, I have degree 3 here and degree 0 here. So this one is going to be degree 3 on the bottom. So now what I do is I see that the degree on top is larger than on the bottom. So just like an improper fraction, when the top is larger than the bottom, it's called improper. So I would say this is an improper integral. So that means for the next direction, it says if improper, rewrite the sum of the polynomial as a polynomial and a proper rational expression. So that's what we're going to have to do here. So we're going to have to rewrite this as the sum of a polynomial and a proper rational expression. So now here we go. So that means we're simply going to have to divide these. And there's no easy way about this. This is x cubed plus 0x squared plus 0x plus 8. So notice what I did is I filled in all of the degree terms that I didn't have. So now I'm going to do the same thing with the one on the inside. So I'm going to go 3x to the 4th plus 0x cubed plus 0, I got an x squared, so x squared plus 0x minus 2. So at first when I started to look at this, I was hoping that they would all be 2 degrees apart. You know, the top is all 2 degrees apart. But when I look at the bottom's not 2 degrees apart, because that's a jump of from 0, so I go 1, 2, 3. That's 3 degrees apart. So it would have been nice if it was 2 degrees apart, because I wouldn't have had to put all these 0x's and x squareds in, because it would have worked out very nice that way. But since I don't, I have to write all these 0x squared, 0x's in, just to fill it all in. And when I go through it, you'll see why. If you don't do that, you're going to run into some concerns and say, oh, I can't add like terms and stuff. So to avoid all that, it's better just to fill it all in. So now I have to ask myself this. What would I have to multiply x cubed by to get 3x to the 4th? And when I look at that, I see that it's going to be 3x. So I go over to the 4th slot over, and I put a 3x there. Now notice these should match degree-wise. And also notice I have 1, 2, 3, 4 terms. So here, 3, 4, I should be above the 4th term. Now you want to make sure you write this in alignment here, because it's going to cause a lot of issues if you don't. So be careful with that. So now all I'm going to do now is take these, and I'm going to multiply it times each of these terms here. Okay, so I don't just multiply it by the first one, I'm going to multiply it by all of them. So when I multiply that first one, I get 3x to the 4th. Now that's this one right here. Okay. And then when I multiply it by the second, I'm going to get plus 0. Yeah. Okay, it threw me off for a second. Plus 0x cubed. Actually, I'll just put it, yeah, I'll leave a 0x there. Actually, yeah, that'd be 0x cubed. Okay, and then I'm going to do the next one now. So now I'm going to do this one here. And that one's going to be plus 0x squared. And then I'm going to do the last one here, and that's here. And that's going to be plus 24x. Okay, so now do you remember how we do long division? I take this whole thing and I subtract it. And I like to put it in parentheses and a subtraction there. So that you know that that negative is going to go to everything in here. Okay, so be aware of that. So now 3x to the fourth minus 3x to the fourth is going to be 0. So that's 0. That's 0. And then here, I'm going to get a 1. There's usually a 1 in front of there, right, if I don't see anything. And then that's 1 minus 0, really. So then that's just going to be x squared. And then this last one here, this one here, is going to be 0 minus 24. So this is actually going to be negative 24x. Okay, so then now what do? I bring down the next thing, which is the 2. So minus 2. So now hopefully you notice here that x cubed, the degree out here, the degree out here is larger than the degree down here. And I could do the whole thing because I should, but I was just circling the largest degree term. So that's degree 3. This here is degree 2. So that tells you then I can't divide it into there by multiplying it by some x or something. So what I would do is I would say plus 0. And then when I multiply this by 0, I'm going to take this 0 here and subtract it. And then I'm just going to end up with this as my remainder. X squared minus 24x. And that was a minus 2, so be careful. So that's my remainder. So in general, when I have a remainder, I can say r x squared minus 24x minus 2, or the way we can formally write this is we would write the 3x, and then we would have a plus here, and then I can write the x squared minus 24x minus 2 over and what I'm dividing with. So I wouldn't write the zeros in here. I would just write as far as we would need to go. So that would be how I would write this, because I wrote this as a polynomial. Polynomial, there's my polynomial, and the proper rational expression is here. And I can say it's proper now because the way I look at this is I say the degree of the top polynomial is less than the degree on the bottom polynomial. So that would be how I would write it. So that would be my answer for that problem.